good morning, good evening, or wherever the fuck you are in the world. Today is the first ever episode of Ripped Mathematics, and today we will be studying group theory. So, a natural question which would arise in your mind is, what exactly is a group? In order to explain this, In order to sufficiently explain this, I'd like to begin by explaining something which we all know and love, our common integers. So, by the integers, we describe the integers as a set, and we call it Z. Now, this is just a fancy name for all the counting numbers which you know and love. So, that would be obviously 0, 1, minus 1, 2, minus 2, 3, minus 3, 4, minus 4, right? And obviously this is going to continue on infinitely long. So now there are some commonalities between the integers. So for example, the first one, which is quite obvious, is that if you were to add two integers, you would get the third integer, which is also an element of Z, right? So basically what I'm saying here is that if I were to add two integers, I would get a third integer, which is also an integer. The second is A plus B plus C is equal to A plus B plus C, and the order in which I perform this operation, will not matter. So I could add A and B and add the result with C, or I could add B and C and add the result A, right? And in either case I would get the same answer. So that is the second thing which is common to all numbers, right? The third is the existence. So before I rigorously explain this, so the third is that for every integer we have this identity, A plus 0 is equal to A. So essentially you add any number to 0 and you will get the number back, right? That is another thing which is common to all numbers. And 4 is the existence of an inverse. So by that I mean that I take any number A and I take the negative of that, I will get the number, I will get back 0. And this is true for all numbers, right? So correct. So I'm going to rub the board, and after that we will explain what a group is a bit more rigorously. So something which we often do in mathematics is that we look at something which we observe in nature and we try to abstract out its properties so that we can apply it to a more general setting. This will become more clear as I continue with the lesson, but for now just keep that in mind. And without further ado, let's move on to the precise definition of what a group is. So, as I said, a group G star is a set together with a binary operation. So, to keep things very general, a group G can be any set. So by set I mean the set of matrices, the set of complex numbers, the set of people who don't like cheese. Anything which is a set can be a group. And by a binary operation we just mean that we take two elements from the group and we get a third element. So that is what a binary operation is. So it can be anything as well. So it can be addition, multiplication, subtraction, composition. So to keep things very general. And we then say that our set together equipped with this operation is a group as long as it satisfies the following properties. So the first property is called closure. So as I said in before, so it would be good if you would keep in mind the integers as we go through this lesson. So we add two elements of our group and we get a third element. That is called closure. The second property is called associativity. So by that I mean that for every A, B, C, which is an element of our group, the order in which I compose my elements will not have an effect. So for example, if I were to compose A and B and then compose the result with C, that should give me the same result if I were to compose B and C and then compose the result with A. And we call this property associativity. The third property is called the existence of an identity element. So for example, in the case of the integers, if we were to add 0 with anything, we will get the number back. So to keep things general, we're saying that there exists an identity element, 0 in the integers, such that for every for every A, which is an element of our group, A star E will give us back A. So basically, for example, 5 plus 0 is 5, 6 plus 0 is 6, and so on and so forth. And the final property is called the existence of an inverse. So we say that for every A, which is an element of our group G, so for example, if we were to look at the integers, minus 5, and there exists a negative A. So in that case, it would be plus 5, such that A composed with minus A will give us back the identity. And by doing so, we have now generalized what it means for an object to be a group. Now, now that we know the abstract definition of what a group is, in the next lesson we will be moving on towards some basic properties of groups and some basic examples. See you until then.